All right, SAT 22, week 13. We have a picture of a graph here. It says this is a rational function. Rational function f is defined by an equation in the form f of x is equal to a over x plus b, where a and b are constants. The partial graph of y is equal to f of x is shown. If g of x is equal to f of x plus 4, which equation could define g? And our usual four answer choices. Well, how do you think we did? We did fantastic, except not really, since it was about 50%, 50.7% specifically that chose answer choice C, which was correct. Whew, a whopping almost 38% chose answer choice B, and we'll get to the bottom of why that answer was so popular. And, most of us did use Desmos, although a good portion of us, over a quarter, chose to phone a friend, and apparently the friend did not have the secret sauce. Okay, we thought this was, ironically, a pretty easy question. Sure, it's skewed a little bit towards the medium side over here, but you can see clearly that SAT people, the College Board, definitely did their job well in setting a trap that a lot of us fell right into. So let's take a look over here at the actual solution. Now, this equation right here that it says is a rational function, the word rational, the root word here is ratio, and this is a ratio of, in this case, we have a constant and a linear function, but rational functions is polynomial divided by polynomial is what happens. And a lot of times when you have polynomials divided by polynomials, you create a situation where you have divided by zero. You might have some number and you divide by zero. And on a graph, what happens? Two different things. And what happens on this one specifically is that you get what's called a vertical asymptote. Asymptote. Yeah, that's how you spell that word. It's a Greek word that means to fall together. And can you tell where this vertical asymptote is? Well, I'll tell you where it is. It is right here at -4. This is a line that this graph, this portion of the graph is getting closer and closer to, and it's never ever going to cross it. There's another one here. Specifically, this one's going to be at 0, but it's hard to tell because we're missing so much of our graph. Anyway, doesn't matter. Doesn't matter. Here's what I'm going to suggest that you do. I'm going to suggest that you select some points on this graph and throw this thing into Desmos to see what Desmos can do for you. So specifically, let's see. I can see that there are some specific dots that are hitting grid lines, and I'm going to highlight each one of those. I'm going to give them some ordered pairs. I'm going to throw those into Desmos and do a regression on it. See if I can come up with this equation. Speaking of that, before I even move on, before I even look at that, there's one of these answer choices I'm going to automatically eliminate, and that is going to be answer choice D. And here's the reason why. If I take a look at the expression here, 6 times x plus 4 divided by x plus 4, these two x plus 4s are going to divide away. It's like 5 divided by 5, 17 divided by 17, that's equal to the number 1, as long as x is not equal to -4. Because if x was equal to a -4, then you got 0 divided by 0. Now that one doesn't make a vertical asymptote. What that actually does is it makes a tiny little hole in your graph. And essentially what this would turn into is y is equal to 6. That's a horizontal line, but x cannot be equal to -4. So really what it is like one of these kind of things. It's a horizontal line. It's got a tiny little hole in it right there at -4. That's not what's happening here if all we do is add 4 to our x's to get g, right? Okay, so yeah, that one's eliminated. Then it's just these three answer choices. And remember that C was the correct one, and for some reason, lots of us chose answer choice B. I wonder why that is. Here, anyway, let's go to Desmos. I'm going to make myself a little table of values and then do a scatter plot based on this. I don't remember what those numbers are, so, oh, I don't think I even wrote them down. Okay, so I won't side by side yet. So I am going to write ordered pairs here. This is -10, -1. This is -7, -2. Over here is -6, -3, and one more in case I need it, which I Probably don't. -5, -6. Okay, there we go. And let's just scatter plot these, shall we? No, that's the wrong guy. This one. Where do you want to go? You want to go over here? Okay, we're going over here. Let's see, we got a -10. Let's zoom in a little bit. -10. And I'm just going to go down and put the x's first. So -7, -6, I believe, and then a -5. All right, and then let's come over here to the y values. And the y values are a -1, a -2, a -3, and then it jumps down to -6. All right, so far, that's what I've got. Let's look at our scatter plot. So those are the dots just carried over from our original graph. And I could hit the little button for adding a regression. Problem is, if you pull this pull down menu, you got linear, quadratic, cubic, quartic, exponential, logarithmic, power, logistic, and sinusoidal. None of those are rational. Garbage. So let's just delete that thing. So what we're going to do is make ourselves a custom regression. And Desmos is really cool in that it allows us to do that as long as we have some form that we think it's going to fit. And it's going to be this guy right here. And so I'm going to type this thing as y1, and you do a little squiggly for regression. And then just this a and this b, these are going to be our parameters that it's going to try to figure out for us. A over x sub 1 for our x sub 1 values, and then plus b. Type it in. Not going to make sliders for us. Although you could have done that. Like, for example, you could have typed this in exactly like you can see, and you can do little sliders, and you can move things around until it just snaps into the points that are on your original graph. You could totally do that, but I'm not gonna. I'm gonna do y1. To get the subscript 1, you just type a 1 after your y, and it'll automatically do that. I think that there's another way to do it. It's around here someplace. I don't remember what it is, but doesn't even matter because I could get it that way. Squigglies under your keyboard here. Oh yeah, there. If you can look right to the left of the 1, 2, 3, that's where the little subscript button is. Okay, and then over here is our squiggly, and then we're going to start this up with a little division sign. Let's go back over here with the A. Down here at the bottom is x1, and then plus our b. Beep. And if you look in the regression parameters, question mark, I wonder what that question mark is. Oh, yeah, that's not what I really wanted to know. Anyway, it gives us our A of 6 and our B of 4. In other words here, I'm gonna type this in as a function as f of x kind of thing. Of course, I could have pulled this equation in, I think. Yeah, I could have exported that equation, but I'm just going to type it in manually. So anyway, so I need a little a there. No, not an a. I need a is equal to 6. I need a 6 there, divided by, and then an x plus 4, right? And I can see that these two things are identical to each other. And why is that significant? That is significant because the graph that they gave us, that is not the right thing. Here it is. The graph that they gave us is this specific one. This is the equation for f of x. And so maybe some of you, what you did if you got answer choice B is that you did all the work necessary on Desmos and you got all of your points to line up with this specific graph and this equation, but that was the f of x function instead of the g of x function, which is the one that we were looking for. Okay, now the next part of this is understanding what g of x actually is, how you get g of x from f of x. So this is something that you usually study in algebra, both algebra 1 and algebra 2. It's just function transformations. And inside here, this x plus 4, what it's telling you to do is move to the left, not right, but move to the left 4. And I'm going to use the actual word here, translate. Translate left 4. And we'll see why that is in just a second here. And I can actually do this on Desmos by plugging in some of these answer choices. So we know that it's either this one here at A or it's this one here at C. And well, I mean, if you just take a look at this, x plus 4, if I plug in an x plus 4 into this equation, x plus 4 plus another 4 makes this x plus 8. I mean, does that make sense? Right? So g of x should be equal to f of x plus 4. So this is our g of, I'll put in an x plus 4, plus this other 4 gives us g of x plus 8, which is in fact this one. Okay, but I'm not done yet. I am not done yet. Let's see why all this stuff is happening and keep going over there for some dumb reason. So what I'm going to do is specifically make a table of values for this guy. So table and then plus. And then let's go ahead and just type in all of the numbers that we actually want. And then we're going to add 4 to them. Is that what I want to do? No. So if I did this, if I add a table of values to this specific one, it's just going to make the same exact table that I have way up here for the scatter plot. So that's not what I want to do. So instead, let's do the actual g of x function. And watch this, watch this. I'll do this as g of x is equal to f of x plus 4. And now this black graph, I don't care for this color here. Let's make this something. Ooh, orange, blue and orange, complementary colors. Okay, so you can see that what I just did there, even if you didn't know that x plus 4 actually moved this thing to the left 4, you can see that when I type this thing in, exactly like what we just got, right? And now I'll make a little table for this one here. So make a little table, and then specifically what we want to do is we want to type in what the x values are that are going to correspond to the original graph. So we put in 10, so this one is going to end up, I think, at negative 14, so negative 14 here. And then I got this negative 1. So if you look at these 2 points, you can see from the blue graph, which was the f of x graph, if you add 4, actually, it's not adding 4 to the x, because you add 4 to the x, you actually move over here to negative 6. But it did translate this graph to get the same exact y value, negative 1. It translated it to the left 4, not to the right 4. Okay, and then the next point is over here at, this looks like a negative 11. Negative 11. You can see that these 2 points match up. And let's see, this next one is at negative 10. At negative 10 gives me 3, so those y coordinates match up. And then the next one here is going to be at negative 9. So negative 9, and then looking at those 2 values, we can see, yes, totally, the 2 y values match up. Okay, so let's see exactly why it is that it moves left instead of right. So I'll show you that also algebraically. So starting with this expression that they gave us, which was g of x is equal to f of x plus 4. And let's say, for example, that I wanted to just pick one of the values that's on here. Let's say that I picked this one here, this negative 7. So in the f of x function, this whole, I know what I want to do. This whole thing was equal to a negative 7. So why don't I just set those 2 things equal to each other? In other words, x plus 4 is equal to negative 7. If I subtract the 4 over, I get negative 11. In other words, g of negative 11 is the same thing as f of negative 7, right? If I plug in a negative 11 in here, negative 11 plus 4 is that negative 7. Right, and then I can see that specifically it moved it to the left 4, not to the right 4. And then essentially what's the reason is that whenever we're doing function transformations, which is what this is a translation in this case, it always works in inverse properties. This says x plus 4. I'm tempted to think that that means to the right 4, but the inverse of that is actually to the left. left 4 minus 4. And you can see why that actually happened here is because when I set these two things equal to each other, I had to subtract the 4. It's like I'm solving an equation, and when I solve an equation, I do this with inverses instead of, just regular PEMDAS. It's working PEMDAS backwards. Now, could I have done this by hand? Did I have to have Desmos in order to figure out what the equation was? And the answer to that question is no. I will show you that you can totally have gotten this equation by hand, and it's pretty cool. It's actually just a system of equations. So f of x was equal to an a over x plus b. And since you have two parameters, two unknown things, two things that are controlling what your equation actually is, this a and this b, this means that I need to have 2 points with two equations in order to solve it. So it's going to be a system with two equations, which I totally know you know how to solve. I mean, we've been doing it long enough, and of course you did it in Algebra 1 last year. So what I'll do is I'll just take 2 points from our graph, any 2 points, we'll plug them in and solve for the a and the b. So one of the points that we'll use, why don't we just go ahead and use -7, -2, -7, -2, and then we will also use -10, -1. Okay, so I'm going to plug this one in first. I don't plug this in for a and b. That's the x value, and that's the y value. So -10 is going to go in for our x, and -1 is going to go in for our f of x, or y. So I have -1 is equal to an a value over -10 plus b. And then I would just multiply this -10 plus b over to the other side to make this a linear equation, which will look like this. So I'm going to have a -1 that's going to multiply times all of this, which is just going to switch the signs. 10 minus b is equal to a. And I'm just going to leave it just like that. That's our first equation. And we need another one, right? If I'm going to solve this as a system. So that's when we will stick in the -7 and -2. Again, -7 is going to go in where the x goes, and -2 is going to go in where the f of x goes. So -2 is equal to an a over -7 plus b. And just like I did before, I'm going to multiply this guy over to the other side. And I'll have to distribute a -2 this time. So it's a -2 times -7 plus b should be equal to a. That's a positive 14 minus 2b is equal to a. And I'm pretty much good to go. If I take a look at these two equations here, they're both equal to a. So I can just do a substitution. I can take out this a here, and I can substitute 10 minus b into its place. Awesome. So I get 4 minus 2b, take out a, replace it with 10 minus b, and we're almost there. We almost have b. What I'll do is I'll just add the two b's over here, and I'll subtract the 10. If I subtract the 10, I get 4. Right in with the laser pointer. 4 is equal to, add the two b's, so this is a 2b minus b is just going to give me b. There you go. You got b is equal to 4. That's the number that was down at the bottom, which is that guy right there. Yes? Again, this is for the f of x function. Okay? And then to find your a, you just come back up here to one of these equations, any one would do, and I have 10 minus b is equal to 4. And to add the b over, subtract the 4 over, and I have 6 is equal to b. That looks like b is equal to b, or 6 is equal to 6, but it's not. 6 is equal to b, which is, that is not, this is, what am I even thinking? What am I even thinking? I put the number in the wrong slot. That should have been 10 minus 4 is equal to a. So 6 is equal to a. There we go. Now that is correct. So 6 is the top number that's right there. And then after that, you think of in terms of function transformation, moving this thing left 4, or just simply substituting in x plus 4 in the place of x, and then you have your equation. So hopefully you learned a whole bunch by taking a look at this pretty sweet SAT question for this week.